I'm very proud of my profession, and CYOConnor is one of Australia's most shining examples of a professional engineer in terms of his leadership, his creativity, his integrity and his values on safety and sustainability. So I'm absolutely delighted to help remember him, his achievements and personal attributes in this small way here tonight. So thank you, I am truly honoured. Nothing is more boring than someone else's family history, but I was encouraged by the National Trust, so blame them, to talk briefly about my family tonight. I will try and keep it brief, and they are more interesting than I am. But I want to do it to draw out two threads, and that's what this sort of avant-garde three there is about. The first, I hope it will help explain why I'm so proud to be here this evening, some family influences in my upbringing, and then something that I'll touch on again at the end is to help illustrate what we can learn from CYOConnor's story, or CY as I've come to know him when I was thinking about this tonight's talk. What we can learn from CYOConnor about the importance of nurturing creativity when embarking on solutions to major challenges. And we do have some major challenges on the horizon. We have a global sustainability challenge, I believe, and within that a carbon challenge, which I'll touch on briefly, and then go down in particular to the broad aspect of energy challenges, that broad area of energy challenges, which is a large and interesting infrastructure problem, and again ties back to CYOConnor. And talk a little about CSIRO's activities to help address the energy challenge, including pathways to a sustainable future, societal preferences, technologies and infrastructure at particularly the demonstration scale, and then have a quick wrap up. So that's the plan. Right, as threatened, the Ronalds family tree. This is an abridged version, highly abridged version. There's a few trends running through that. One is the family name Francis, which I didn't manage to dodge. Another is the rather prominent Ronald's nose, which I didn't do a good job of dodging either. I was quite interested that we have a little bit of gold rush experience in the family. My grandfather was at Coolgardie in the late 1800s, and my great-great-grandfather spent his last years in the Ballarat gold rush. But I actually want to draw out the engineering connections. So talk a bit, if I may, about my dad and my great-great-great-uncle. Okay, so Dad first. Dad's career as a civil engineer was a little bit like CYOConnor's in terms of its breadth. He dabbled in harbours, in railways, in pipelines, albeit it was gas pipelines, not water. Here in this period here, and this was the gas pipeline that really kicked off natural gas distribution in Australia. And he was Engineer-in-Chief at the Melbourne and Metropolitan Border Works for 13 years. His key area was water supply. Just after the war, he was appointed to the National Committee to investigate the feasibility of the Snowy Mountain scheme. And he then went on to become the first Chief Civil Designing Engineer of the Snowy. And when he was doing that research as part of investigating the Snowy, he wrote a paper, Water Supply Problems in Dry Areas, looking at different solutions around Australia. And this is, I hope you can see it, it's not a very good copy, a diagram from that paper. Interestingly, most of the pipelines built, this one here, the suggested Wimmera pipeline project, actually has only just been built. It was started a few years ago and finished last year, and built at the time as Australia's largest water resource infrastructure project. But the paper was actually all about the Goldfields pipeline, which Dad described as the noble and daring conception of Mr. CYOConnor. Dad had real respect for WA engineers' creativity. I remember that very well. And he absolutely, I remember him talking to me about CYOConnor. He admired him immensely. The practical solutions he developed, the fit-for-purpose solutions for our local conditions, which he put down to our relative isolation at that time. And I've actually seen that in my industry more recently, in oil and gas, where there are a number of first-of-a-kinds globally in Western Australia around platform design types and methods of construction. And I certainly hope we don't lose that ingenuity as we continue to become part of a global village. But creativity can attract criticism, and my dad experienced just a little that I remember in the 50th, in the lead up to the 50th anniversary of the Snowy scheme. And that was soon before he died. It wasn't personal criticism, but I think Dad did find it quite difficult to the point where he didn't go to the 50th anniversary celebrations, albeit that criticism is for understandable reasons given changing views around environmental values. Okay, on to Sir Francis. An early electrical engineer, and emphasis on early. He was dead before Thomas Edison had developed his incandescent light. He invented the electric telegraph, and that's a picture of it there. He set up 8 miles of wire in his garden, some of it hanging between those frames and other parts of it buried 4 foot deep in the garden. He never married, so I think that's why he was able to mutilate the garden in this way. After the trial worked, he wrote down his vision, and I'll pause for a second if I can and let you read the vision. The italics is his. It's great language, I reckon. It's also quite a bold vision. So what happened next? Well, he sent his proposal off to the British Admiralty and got an official response pretty quickly. Telegraphs of any kind are now wholly unnecessary. And that's in comparison to visual semaphore that was the method at the time. And then the Prime Minister waded into the act and said that the current telegraphs are so perfect that I doubt if they could be improved. And certainly improvements, if they're forthcoming, must not be looked for in this ingenious electrical toy. So there wasn't quite a strong reaction to an innovative idea. It all ended well. Sir Francis downed tools. He went on extensive travels around Europe and the Eastern Mediterranean, which can't be bad. 21 years later, his work was patented by a rather well-known name in electrical engineering, Wheatstone. Started being installed in London, and the rest, as they say, is history. So the point of these examples and the link to CYOConnor, for me, I'd like to bring out that changing times depend on innovation. Changing times also instill uncertainty and attract criticism. Now, supportive, constructive, open debate clearly is essential, but unfortunately for CYOConnor, it wasn't that. It was often ill-informed, acrimonious and defamatory. So I believe we can all learn from CYOConnor's story today in how to support innovation, because we need it now. Okay, so we've got changing, challenging times. CYOConnor solved the water security challenge in regional Western Australia. And now we have, I believe, a broader global sustainability challenge. And this graph illustrates the carbon aspect of that. This is the global carbon budget put together on about an annual basis by the Global Carbon Project, which is an international team that actually CSIRO has co-chaired for a number of years. So what we've got here is CO2 flux. Now, the main source of emissions is labelled here as fossil fuel emissions since industrialisation. It's not the only source. They also list here deforestation, but it's certainly the main source. Fortunately for us, nowhere near all of those emissions stay in the atmosphere. We've got two big sinks. One is the ocean sink, and the oceans are slowly acidifying, and the other is land sinks. And the most obvious example of that is that trees absorb CO2 in photosynthesis. Now, nobody pretends these numbers are completely accurate. You can see the plus or minuses here. And by the way, PGC is petagrams of carbon, and a petagram is a billion tonnes in the old language, my language. But the most accurate of these various predictions and measurements is the amount of CO2 in the atmosphere. And you can see it goes up and down a lot due to changing weather patterns, etc. But the overall trend is certainly heading up. Now, this is not my area of expertise, but as an engineer looking at this from a risk management perspective, this is a scary full-scale experiment to be running with our globe. And I think we need to do something, and we certainly need to do something in this area, which is energy. Okay, so what are Australia's energy projections? So this is data from ABARES, and it's primary energy consumption in exajoule. Now, we see here from the different colours the oil in green and the coal in grey and the gas in, what would you call that, puce. That, and we've got the renewables down the bottom, is that fossil energy dominates. Australia runs on fossil energy, and indeed the world runs on fossil energy. We're just starting to see perhaps a reduction in coal consumption due to current policy directions. But overall, our energy demand continues to increase, and that is not good for CO2 emissions. The renewables down here has actually been amazingly consistent over the last 40 years, and that's actually largely traditional biomass. We're just seeing this little tiny kick up here, and when you consider all the solar cells we see around, all the wind farms we know have been built, I'm hoping that little tiny kick up there gives a sense of the scale of the challenge we're facing and the scale of the change that needs to happen. Currently, wind and solar provide less than 1% of our primary energy consumption. Okay, now adding production into the mix as well. So production and consumption, which is why the previous graph was such a silly scale. So if we look at the similar colours, so like the black and the grey, we can see that Australia's been exporting coal for a very long time. Australia is the world's largest coal exporter, and there's absolutely no sign of people's demand for our coal diminishing. We've been exporting gas since the North West Shelf started up in '89, and we export virtually all of our uranium. So we are major energy exporters. We export nearly 80% of what we produce in terms of energy. So we play a significant role in terms of the energy security of the region, and it provides a significant source of wealth for Australia. $46 billion last year, 27% of our export commodity value. And energy also contributes 5% of industry gross value added. So for me, when we're talking about energy, we have three important attributes to balance: the security of supply, both regionally and domestically, prosperity, and emissions reduction. So what if we want to change our future energy mix? What are the choices that we have? So this is data from the Australian Energy Resource Assessment provided by Geoscience Australia. And we've got the traditional sources, if you like, up here, resources. So we've got lots of coal down the east coast, we've got lots of gas up here, and we've got a fair chunk of uranium as well. And then down here we've got, if you like, the more prospective energy technologies. So you can see, for example, oh, you probably can't actually, it's a bit light, but hopefully you can see that we've got a lot of solar energy potential. We're actually the continent with the highest solar insulation per square metre. We also have a lot of geothermal energy potential. Apparently we have some of the hottest rocks in the world. We've got a lot of wave energy potential around the south coast, world-class resource. We've got a lot of wind, we've got a lot of tidal. We've almost got an embarrassment of riches. The only thing we don't have a lot of is oil, and I meant to mention that in the previous slide. We had peak oil in 2000, and we've had a slowly declining oil production since then, while demand continues to increase. Unfortunately, oil is the most valuable of the commodities, so that's actually turning into quite a significant trade deficit. But apart from that, we've got a rich endowment of energy sources. Not that these prospective technologies are without challenge. You can see a lot of it is quite remote from population centres. Not that people want new power plants to be near where they live necessarily. The technology is not yet proven, and it's more expensive, which is why, of course, they're prospective alternate technologies rather than the current ones. Okay, so I'm hoping that's a little bit of a thumbnail sketch, very briefly, of the energy landscape. Now I'd like to turn into what CSIRO is doing to help Australia address these various challenges and opportunities. And this, if you like, is our strategy on a page. So our vision is to bring together the triple goals of clean energy, energy security, and wealth creation from energy. We are focusing in particular on helping to accelerate large-scale greenhouse gas emissions cuts while ensuring a smooth transition to a new future. And to do that, we're looking at three primary mechanisms. One is major coordinated initiatives. In many of these areas, we need to bring together, I believe, governments, industry, and the community together with the researchers, and we really need to coordinate nationally. This challenge is big enough and urgent enough that we all need to be facing in the same direction. Another mechanism is to focus on scale-up of new technologies, getting out of the lab and into the field. And then, as CSIRO, we also have an important role to play in providing trusted scientific advice. Okay, so let me just now give a few examples of some CSIRO projects, and starting now with the scientific advice, and this is advice for the community. A community opinion is really important. It's actually step one to achieving change, and we can all help reduce emissions. So a couple of areas where we're working in. The first is the Energy Mark project that we're rolling out at the moment. And with Energy Mark, we ask for volunteers, and each volunteer sets up a communication group with friends and family, kind of literally round the kitchen table, to have a discussion about climate change and options for reducing emissions. And they have that discussion based on materials that CSIRO provides, and CSIRO's available at any time to answer concerns or queries, clarify any points that come up in discussion. So the primary aim for that is absolutely to encourage people to be better informed and empowered about carbon options. And there's a couple of secondary benefits in that in the course of doing that, CSIRO actually learns about changing community attitudes, and that in turn is rolled up to assist government make informed decisions on energy policies and also to assist industry. The other example I'll just mention quickly is the energy book, if you like, the CSIRO Diet Book for Energy. And it was published last year, and it's got a whole lot of practical guidance around helping you measure and reduce your carbon footprint. So lots of ideas, and they're costed, and their relative impact on emissions reduction is quantified so that anybody can decide what ones might suit their lifestyle, if any, and then what effect they might be having on the environment. We're also providing advice to government, and one way that we're doing that at the moment is around modelling integrated scenarios to help visualise economic and sustainable pathways to our desired future. And this again is to help in government policy development. So we can't solve particular problems like what our energy future should be in isolation. Our sustainability challenges are all interconnected. And so one example of that we're working on at the moment is what is the optimal land use going forward across Australia, because there's a whole lot of calls and will be more calls in the future around land use. So we've got to balance a whole range of things like food security globally with a growing population. We've seen the huge potential for CO2 biosequestration, planting lots of trees. We've got ecosystem health and biodiversity, which is becoming increasingly valued. We've got bioenergy. We've got ongoing community sustainability and development. And then we've got water availability challenges and climate variability. So how does all that mix come together between now and 2050? And what are the policy implications for that for government to consider? It's a nice complex problem. Now, the next level down, looking at Australia's future energy mix. And this modelling was incorporated into the Garneau Climate Change Review and is actually in the updated one Garneau's doing at the moment. We're also updating ours. So this is hot off the press. So again, it's looking at various scenarios. This is not deterministic. This particular scenario is CPR is 5, so it's a 5% reduction in emissions by 2020 versus 2000 and a 60% reduction in emissions by 2050. So it's quite similar to current policy directions. It's also electrical engineering. It's a subset of energy. So again, we see that in the past, nearly all of our electricity was generated by either black or brown coal with a bit of hydro on the top. In the last few years, that's just been beginning to change. We're seeing take-up of gas in the white and to an even smaller degree, some wind and some biomass there. And then in order to achieve the carbon cuts for this scenario, you've then got this blossoming happening any day now, like as soon as possible, into all these alternative technologies. So a big growth in wind, a big growth in solar, to a lesser degree, some hot fractured rocks in this scenario, that's geothermal, some wave, some nuclear, and interestingly, a big chunk of coal still, but this time with carbon capture and storage to make it cleaner. Now, this rainbow is really exciting if you're an engineer, but it's actually a huge systemic change to be facilitated, and now's the time to do it if we're going to do it. I just want to stress again, these are scenarios, not reality. they are inherently uncertain because the solution we go for depends on community opinion, government policy, on market forces, technology development. There's nothing deterministic about it. But this model and most models around the world show that there is no silver bullet. We're going to have to pursue a range of technology options. Okay, so looking now at some of those technology options that CSIRO is participating in, and as I say, the focus on demonstration at scale rather than R&D, so that we can learn by doing to help reduce cost and risk over time. The logos in these next few charts are just the prime partners, sponsors, and collaborators in these various projects that I'm mentioning. Right, so the first one is geothermal energy, and this is based on the fact that the Earth gets hotter as you go down. I'm mentioning here two types of geothermal energy technology. The first one is hot sedimentary aquifers, where you drill a couple of wells. You drill one well to bring the hot water up to the surface. You then use the heat for heating, or perhaps less intuitively, you use the heat energy for cooling through an absorption chiller, and then the cooler water goes back down into the aquifer and you set up the system. This is potentially a really nice solution here in Perth because we've got a hot aquifer underneath us. And through the Geothermal Centre of Excellence, we're looking at a couple of demonstration possibilities right here in Perth, and probably going down about 3 kilometres, because extrapolating the existing data, no one's actually been down there, but extrapolating it, we reckon we can get to 100 degrees at 3 kilometres. The hotter it is, the more efficient it is. And we're looking at one demonstration possibly right here at ARC, and another one at UWA. The next level of sophistication is hot fractured rock. And geodynamics at the Cooper Basin are going down 5 kilometres, and they're getting to 280 degrees. And that's enough to be able to use the steam directly to generate electricity from steam in the traditional way through a turbine. Both of these areas are in different ways first of a kind globally. So very exciting, but particularly exciting to think that we might have low emissions energy from under our feet. Second one, solar energy. And again, mentioning here a couple of different technologies. The first one is concentrated solar thermal, and CSIRO has two pilots here. This one's existing, it has for a few years, and this one's currently being built, which is why it's just a schematic. And the idea here is you have this array of mirrors that focus the sunlight up to a reactor, which then heats some fluid, and then you do something with it. So the common thing is steam, and again you generate electricity. With this second demonstrator, we're actually going to use the solar Brayton cycle system, and that's heating compressed air rather than water, heating it up to 1500 degrees C, and then running it through a gas turbine to generate electricity. And we feel that might have some potential advantages in parts of Australia where there's a limit on water. The other area we're also working in is photovoltaics, and that's this picture down here. Australia actually is a real centre of excellence for photovoltaics. That's solar cells that convert the sunlight directly into electricity and then have it flow through a semiconducting material. A lot of expertise in particularly the University of New South Wales and ANU. And that's using silicon. What CSIRO is doing with many partners is developing the next generation of photovoltaics out of cheaper, flexible, printable plastic. And the idea of these is that you'll be able to just roll them out across building surfaces, or perhaps even embed them in building materials, to generate electricity on the roof. And the picture down there is of a manufacturing trial done in Victoria last year. The other one I mentioned just briefly is the Solar Flagships program. So this is a program put together by the Australian government to scale up solar to the next level. I believe there's currently 7 shortlisted projects. CSIRO is involved in most of them, and there could be some announcements around which ones will go forward over the next few months. So it's starting to happen. The next one is CO2 capture and geological storage, CCS. And this is one of the few feasible ways of reducing emissions from fossil energy like coal at considerable scale. So the idea is that you capture the CO2 at its source, like the power plant, and you then inject it, perhaps 1 or 2 kilometres into the ground in a place with suitable geology, and a place that will certainly trap the CO2 for a very long period of time, thousands of years, and you then monitor it very carefully to make sure it does behave as you expect. And then between those two, you've got some means of transport from the power station to the suitable geology, which could be anything, but it is likely to be a CO2 pipeline. So we're involved in all of the key steps on that chain. First of all, post-combustion capture that actually captures the CO2 before it goes up the chimney. And there's the pilot plant there sitting in the power station. That one's actually New South Wales. We've got 4 of these running, including one in Beijing that was opened just before the 2008 Olympics. And then on the storage side, we've got actually one of I think it's the largest research demonstration of CO2 storage in the world in Australia, in Victoria, led and operated by the CO2 CRC. And CSIRO has played a significant role in that. And one example is the modelling to actually predict how the CO2 will behave, its long-term fate. And these sort of predictions are using technology from the oil and gas industry, albeit you're dealing with a different fluid, and albeit you're modelling it for thousands of years rather than just a few. You can see that that's the accumulation after 1140 years. We also have a flagship program funded by the Australian government in this area that again hopes to really scale this up and make it work as an integrated system for the first time in the world. And there's 4 shortlisted projects, I believe, at the moment, and again we'll see some announcements, I think, over the coming months. So that is starting to happen. But we must also mention Chevron's Gorgon project, where it's actually happening for real as we speak on the Northwest Shelf, a commercial project, not a demonstration, the world's largest geostorage, CO2 geostorage. And I believe they're planning to inject 100 million tonnes over the project life, which, to put it in perspective, is about 20% of Australia's annual emissions. Last, I'm nearly at the end, a change of pace from energy supply to energy management, distribution and use, which is another key part of energy infrastructure. Australia actually has the world's longest interconnected power system, the NEM, the National Electricity Market, which is kind of funny because it doesn't make it to Western Australia. I know there was a report written a couple of years ago that estimated that up to $500 billion might need to be spent in Australia on energy infrastructure to 2030, which again in context is half our GDP. And the challenge with these scale of investments is they're long-term decisions, and yet that of course is challenging when the technology is evolving so rapidly. So I've listed here some of the challenges we have on energy management of energy delivery and use. First of all, you've seen from the rainbow that we're talking about a diverse energy mix, much more diverse than we've had in the past. We're also talking about much more distributed remote generation. Rather than just a few coal-fired power plants, there'll be many more smaller power plants, including, you know, on your roof with your solar cells. You know, you can generate your own power, so that's how distributed it can be. We've also got intermittency to deal with. What happens if the wind dies down or at night when the sun's not too good? And also, as I've tried to illustrate, these are new and less mature technologies. And then the last one I've mentioned is growing peak demand. Actually, these days, the peak during the day is in summer when we turn on our aircon, and that peak is getting peakier. It's growing faster than the average daily consumption. So managing that demand through the day is another challenge. So what CSIRO is doing about this, and of course there are many others as well, wrapping up under the heading of smart grids, and I'll just mention a couple of areas we're working in. So first, in a system as complex as that, it's nice to have energy storage. And the battery is one obvious example of energy storage. And our Ultra battery, which is a high-performance battery, is now actually in production, funded by the US Department of Energy. And it and other batteries have applications both in terms of stationary energy storage and transport energy. So in the stationary energy side, we've got a demonstration running at Hampton Wind Farm, where you combine the batteries with wind forecasting. So you bring the two together in order to smooth the supply of power to the grid to match the demand. You know, bring the two aspects together. In terms of transport energy, there are many options going forward, but on this one, we're talking about hybrid electric cars or electric cars, and even better if they're plugged in. And we've actually got a trial going in Victoria at the moment with 60 of these plug-in vehicles, just monitoring how they work, what sort of recharging they need, etc. This is quite an exciting opportunity, because when you come home at night and plug your car into your house, you've actually added a battery. You've added storage to your local grid, or if you've got thousands of these, you've got thousands of big batteries hanging off the grid to provide a lot of storage. So that can help with intermittency and peaky demand, because you can manage when are you going to draw the power from the grid to charge your battery, or when are you going to take the power from the battery for your house. So you can actually manage that and smooth it all very nicely depending on intermittency and demand. But in order to manage that, you need smart grids. I mean, it wouldn't work at all if everyone just came home at the same time, 7 o'clock, plugged the car in, you know, you'd have a blackout. It's actually managing that through the day and through the night across the whole system. And Australia's first integrated commercial size smart grid is actually, again, funded by the government. It's just being rolled out at the moment. It's an Energy Australia initiative, but CSIRO's involved, and headquartered in Newcastle and spreading down to Sydney. Okay. So, to wrap up, our sustainability challenges, our carbon challenges, our energy challenges are, I believe, urgent, large-scale, complex, uncertain, costly, long-term. It's not all bad news. When there's challenge, there's opportunity. There's huge opportunities here for us to invent and develop entirely new industries. I think we all need to work together to deliver the solutions, because solutions are dependent first and foremost on community opinion and action, and then government policy and market forces and new technology and infrastructure. At CSIRO, we aim, where it makes sense to facilitate that journey in any way we can through a collaborative research program, and particularly the areas I've mentioned tonight are economic and sustainable pathways, community outreach, and technology development and scale up. You know, learn by doing. we do need to learn by doing. No one has all the answers, and mistakes will be made. And change of this magnitude, therefore, naturally generates critique. Unfortunately, today we again see that some of that debate can become ill-informed, it can become personalised, it can become toxic. So hopefully we can all discourage that, as we need to nurture creativity, not stifle it going forward. So I believe it's good to remember CYOConnor's story and be inspired by it. Thank you very much.